Welcome to the Show and Tell 2 presentation for our app Study Sage. In this segment, the team will be walking through the threaded design architecture that powers the entire application. Our architecture separates components into two main categories based on threading. On the left in green, we have the UI thread containing our main thread components. This includes our main activity handling app cycle, navigating system managing screen transitions, and our compose UI screens. These UI components handle only three things: displaying the interface, capturing user input like taps and text entry, and observing state changes. They perform absolute no heavy processing. On the right in orange, we have our background thread components running on separate threads. First, we have view models running on background threads. These include auth view model for login logic, course view model for course management, notes view model coordinating AI processing, group view model handling real-time operations, flashcard view model managing AI generation, and games view model like game lobby view model and gameplay view model. Second, we have repositories running on input-output threads. These includes auth repository for Firebase authentication, course repository for course data, notes repository for file processing, group repository for real-time messaging, flashcard repository for AI content generation, plus specialized repositories like podcast repository and quiz repository. These background components coordinate with the external services like Firebase APIs, Gemini AI, Cloudinary CDN, and PDA Box, each running on their own isolated threads. Here's a concrete example when a user uploads a PDF to generate a quiz. UI thread captures the tap on note screen and calls a view model. Notes view model executes on a background thread and calls notes repository. Repository handles file operations on an input-output thread called PDA Box for text extraction on a separate thread, uploads to Cloudinary on a network thread, and sends content to a Gemini AI on another network thread. Once AI generated the quiz, repository saves to Firestore database and notifies the view model, which updates the UI thread. The entire process takes several seconds, but user can navigate, chat, play games, or use any other feature without lag because the UI thread never blocks. Let's see the app demo now. When users sign up for the first time, we send a welcome onboarding email containing all the important information about the app. We have used the recent email service API to implement this. On the top right, we can see the profile page where user can view their daily streak and the number of groups they are part of. We also have an XP system that increases when users engage with the app. It has not yet been fully implemented. Additionally, we have a notification section where user can enable or disable study reminders. On the home page, we have daily tasks and quick actions. Daily tasks are yet to be implemented. In quick actions, user can create quick quizzes and quick flashcards for practice purposes. These are not saved to the database and are designed for immediate study sessions. Moving to the course section, users can view all their added courses. Upon clicking on a course, users see all the notes uploaded to that course. When selecting any uploaded note, users are presented with the multiple options including downloading the note, viewing AI summaries, accessing flashcards, generating quizzes, shading via NFC, and listening to notes in podcast format. We will now dive deeper into flashcards. Upon clicking generate, users are shown some preference options, including number of questions and difficulty level. Flashcards are generated using the function generate flashcards and shuffle using the function shuffle flashcards. We are using the Gemini API to implement this. This is the main flashcard interface. Upon clicking flashcards flip to reveal answers, user can also shuffle flashcards, navigate to previous cards, and regenerate flashcards if they want to adjust preferences. Moving to podcast generation, it takes a few seconds to generate the podcast. It is generated using function generate podcast. Once generated, users can listen to the audio and view the transcript. For converting text to speech, Google TTS and function convert text to speech is used. The user has the ability to play, pause the podcast, and listen to it on the go. Since we clicked on this PDF, it now appears in the recently opened section of the homepage. Clicking on it takes us back to the exact note in that course. There's also a See All button where users can see all recently opened notes in a list with a Clear All option to remove all entries. Pull to refresh is another implemented feature that allows users to refresh the app content. Moving on to the groups page, user can see all their groups they are part of. Finally, moving to the games page, we will demonstrate two working games, Study Tacto and Quiz Race, with two players playing simultaneously. We can see that initially the host creates the game selecting Study Tacto as the game. The host also has an option to either write name of some topic or add a PDF. The game is then started using the host game function as shown on the screen, and a unique 6-digit alphanumeric code is created. This code can be used to join the game, which is handled by the function join game by code. The other player joins using this code. Now both the players are in the game lobby and we have an option to mark ourselves as ready. Once game starts, we can see the host gets the first turn and is shown 4 options to choose from. If the user gets the answer correct, then their X is marked on the board and it is also visible to the other player. Now the turn is of the other player and the player also answers correctly. Fast forwarding it to the end, we can see that the control passes from one player to the other as they continue to play the game, which is handled by the functions board update and turn update. The person is not able to click on the board unless it's their turn. We can see that the answer is not correct, the X or O is not marked. In the end, we see the other player got the right column and hence gets the win. Now we look at the second way the game can end, a draw. A draw happens when all 9 positions on the board has been filled and neither player has achieved a winning pattern. To detect this, the game uses a function called check winner. Once the board is completely filled and the check winner returns null, the game will result in a draw. This ensures the game can clearly recognize and display a tie when both players have made all their moves without securing a victory. Now we will take a look at Quiz Race, a multiplayer quiz style game. Each question must be answered within 30 seconds or the game automatically transitions to the next question, marking it as unanswered. This functionality is implemented using the next question function, which sends a message to all clients to simultaneously transition to the next questions. We also provide users with a brief summary for questions they didn't answer to ensure they understand the concept. For each correct answer, users are awarded 250 points, while incorrect answer or timeouts results in no points. The submit answer function ensures that all answers are correctly submitted and scores are updated in real time using the score update function, maintaining synchronization across all players in the game session. We will now present the division of tasks. Starting with Kabir. He implemented the AI-powered quiz generation from PDFs and built the entire PDF upload and processing pipeline. He collaborated in the development of both game modes and fixed multiple bugs across the app. Moving forward, he'll be working on adding PDF support for the games feature and addressing UI-related bugs across all game screens. Next, Manav. He added real-time multiplayer functionality using WebSockets and created the entire backend for the games module. He developed the Quiz Race and Study Tacto games and built the course website. His upcoming work involves fixing API endpoints and adding fallback mechanisms in the front end to ensure reliability even during service failures. Moving forward to me, Akaaljot. I integrated the recent email service with the team's custom domain to enable automated communication with users. I also worked on the quick actions on the homepage and connected both recently opened PDFs and study streaks to the backend. I have also improved the notification and smart reminder features, and my next focus is completing the XP system and refining the overall UI. Moving forward to Yadhu. He completed the flashcard generation feature and developed the podcast feature by implementing audio processing and automatic transcript generation. He also maintains the course website. Moving forward, he'll be fully implementing the podcast feature and continue improving the website. Finally, Ansh. Ansh developed the basic UI for the Groups tab, enhanced the group chat interface, and implemented end-to-end NFC support for document sharing. He also added real-time messaging in groups and Cloudinary file uploads. His upcoming work focuses on UI enhancement and fixing interface bugs across the app. Moving on to the final submission. Our team will focus on 3 major areas: progress tracking, multiplayer games, and the podcast feature. First, for progress tracking in the XP system, the gamification features such as XP, streak rewards, and leaderboards are not fully implemented yet. Daily tasks currently exist as placeholders, so the team will be connecting them to the database and completing the entire progress tracking workflow. Next, improving the multiplayer games feature. The team has already developed 2 games, Quiz Race and Study Tacto, and will now focus on fixing major known bugs across the game screens. The UI for the games module will be upgraded for consistency, and the existing backend will be fully connected so that player states and game results can be stored properly. The backend server will also be deployed to enable stable multiplayer functionality. Finally, for the podcast feature, the implementation is partially complete. The team will add key playback enhancements such as speed control, volume adjustment, and skip forward or backward. They will also store generated podcasts directly in the app and introduce a download to device option for offline listening. Thank you everyone for listening.